so in this video, I just want to go through the concentrations, or how you express, I suppose, concentrations of solutions. Now, you got a PowerPoint in 5th year on concentration of solutions, and it starts off talking about, it's kind of like revision, of junior cert solutions. So what's a solution? So a solution is, a mixture of a solute and a solvent. The solute is the substance that you're dissolving. The solvent is the substance that's doing the dissolving. So the liquid, in most instances, it's water. And then for chemistry, you need to be able to express the concentration of solutions quite a bit. So remember, like a dilute solution and concentrated solutions, we'll talk about those. So I suppose the first part of the chapter is expressing the concentration. We have 5 ways of expressing concentration. So you remember, we have percent weight per weight, okay? You have percent weight per volume. You have percent volume per volume, parts per million, or we also then have molarity. Now, molarity is the way that chemists would use. It's the most common way that we would use to express concentration. You do need to know the percentages as well. Parts per million comes up a bit in the water chapter. Do you remember, where you're expressing concentrations of quite dilute solutions? You use parts per million for that, okay? So let's just revise quickly each method, I suppose, of expressing concentration, and then I'm going to do a few exam questions at the end. So the first way is percent weight per weight. Now, they're using the term weight there. They really should be using the term mass, because units in grams. So it's unfortunate that they're using the term weight, but that's what they use. So weight per weight would mean, so if you've got a 12% weight per weight, what does that mean? It means that you've 12 weight means grams in percentage implies 100. So 12 grams in 100. So if I said to you, I've actually got 200 grams of that solution, then I'd have 24 grams of solute, okay? And then if you got an example like this, look, if they told you that they had 22.5 grams of HCl in 125 grams of solution, but they want you to express that as percent weight per weight, you must bring this down to 100, okay? So how will you do that? Well, the easiest way I think of doing that is if you'll divide both sides by 125, that brings it down to 1 gram, and then multiply by 100 to bring it back to 100 grams. And that's what they're doing there. They're dividing by 125 to bring it to 1 gram, and then multiplying by 100 to bring it to 100 grams. Okay, so that's that first one. Now the next one then that you have is percent weight per volume. Okay, so with percent weight per volume, they might say something like 30% weight per volume. And what does that mean? Weight implies grams, so 30 grams. Always percentage means 100, and V implies cubic centimeters. Volume, units for volume, cubic centimeters. So if you see something like 0.091% weight per volume sodium chloride, what does that mean? Well, that means that you have 0.91, okay? W means grams, percent means 100, always 100, and V means cubic centimeters. So if you saw on a bag of saline 0.91% W by V, then what does that mean? 0.91 grams in always, like I said, 100, and then V means volume, cubic centimeters. Now the question here, look, they're saying that 1.4%, right, W by V solution of calcium chloride, that should be a 2 there, is required for an experiment. If you need, so you want 250. So now the first thing you should do is write down, what does 1.4% W by V mean? So it means 1.4, now W means grams, always, because it's percentage, it's always 100, and V means cubic centimeters. So write down, get rid of the percentage sign, because that can confuse people. So the minute you see 1.4%, 1.4 grams, because it's W, in 100 cubic centimeters. Now, if you need 250 cubic centimeters, then you need to bring that up to 250 by multiplying by 2.5. But if you multiply that side by 2.5, then you must multiply this side by 2.5 as well, and you'll get your answer then, 3.5 grams. Is that okay? Now, So that's done. Now, the next one then that we're going to do is percentage V by V. Now, V by V is generally for like alcoholic drinks or something like that. So if you saw 9.9% V by V, V by V, what does that mean? It means 9. Now, V is volume, so that's cubic centimeters, always in 100 cubic centimeters, okay? Now, if you saw a bottle of wine, 14% V by V, write down for yourself, what does that mean? It means that you have 14 cubic centimeters in 100 cubic centimeters. So if I drank 100 cubic centimeters of this wine, I would be drinking 14 cubic centimeters of ethanol, okay? Now look at the question. It says a person actually consumes 40 cubic centimeter glass of the wine. So how much are they consuming? Well, divide by 100 to bring it to 1 cubic centimeter. Both sides by 100, of course, and then multiply by 40 to bring it back up to 40 cubic centimeters. So divide by 100, bring it, how much ethanol would you have in 1 cubic centimeter? Multiply by 40 then, and you'll get your 5.6 cubic centimeters for that. Okay, then parts per million then. Again, remember we said for very dilute solutions you'd use parts per million. A part per million is a milligram per litre. That's important there. Okay, and if they said to you that they had 0.003 grams of lead in 250 cubic centimeters, what's the concentration in parts per million? So the first thing is you need to bring it to milligrams per litre, right? So I would bring it to a litre first anyway. So you multiply by 4 to bring it to a litre. So that would be 0.003 times 4 in a litre. Okay, so now I have it in a litre, so 0.003 times 4 grams. But now I need to bring it to milligrams. So milli implies 1,000. So then you'd multiply by 1,000 and you'll get your 12 parts per million or 12 milligrams per litre. Okay, that's that one done, sorry. And then finally, molarity. Now this is the most important one in terms of chemistry. We talk about moles per litre. Most common method, look, of expressing concentration. So 1M, the minute you see capital M, you are thinking moles per litre, or that's another way that they used to have of writing it. A 1 molar solution contains 1 mole of solute dissolved in a litre of solution. Okay, so we'll just do a calculation there now on that. So if the solution was labelled, okay, 0.15 molar HCl, how many grams of HCl are present? Now, the first thing I would do if I was you is what does the M mean? Well, 0.1 M, capital M, means 0.1 moles of HCl per litre. So now they want to know how many grams. So try to figure out what are they asking you in the question. How many grams of HCl? Well, if I want to go from moles to grams, I need to multiply by the MR. The MR of HCl is 36.5. So when I multiply that, then you get your 5.475 grams in a litre. Okay. What about if they asked you this way? Look, 4.9 grams of sulfuric acid in 100 cubic centimetres. And they want you to express that in moles per litre. So it's grams in 100 cubic centimetres. So the first thing you would do is bring it to a litre, so multiply by 10. So that should be 49 grams in a litre. So now I have it in a litre, but I need it in moles. The MR of sulfuric acid is 98. How do I convert grams to moles? Number of moles, you're dividing by the MR, divide by the MR and you get your 0.5 moles per litre there for that, okay? That's done, sorry now. Now, effective dilution. Now remember for your vinegar, particularly your vinegar titration, and when you're diluting something, you're only adding water, okay? So, you know, you're adding in water to wash off to wash out the conical flask or something before you do a titration. Well, when you're adding in water, you're not actually changing the number of moles of solute that are present. Yes, you're diluting the solution. Yes, of course you are, because you're adding water. So you're diluting the solution, but you're not changing the number of moles. Can you see here they're representing the actual molecules of solute as those brown dots. So the same number of brown dots remains, even though you have added water. So yes, you have diluted the solution, but you haven't changed the grams of solute or the number of moles of solute. You would have used this dilution formula to calculate dilutions. So here, remember, your 18 molar is your concentrated solution. This is the dilute solution, look, so fill in your formula there. We want to know what volume, V conc, is your unknown. 18 is the molarity of the HCl, the concentrated HCl, and then 250 of the 0.5 molar dilute HCl solution. So what would you have to do? You'd have to measure out 6.94 cubic centimeters of the concentrated 18 molar HCl, and then bring that up to 250 to get the 250 cubic centimeters of the 0.5 molar HCl solution that you would need. Okay, so that's using your dilution formula. Now, these are 2 exam questions that I could find on the on this sort of thing. Okay, so look at the first one. It says calculate the mass of sodium chloride required to prepare 500 cubic centimeters of a 0.9. Now, 0.9 solution, what does that actually mean? So write it down for yourself. 0.9. Now it's W by V, sorry. So W means grams per. Percentage, always 100. And V means cubic centimeters. So that's what I have currently. Okay. What mass? Calculate the mass. So they want grams. Try to figure out what they're asking you. What mass of sodium chloride would be required to prepare 500 cubic centimeters? So I know if I wanted to make 100 cubic centimeters of this saline solution, then I'd need 0.9 grams of sodium chloride. But for 500 cubic centimeters, then I'd have to multiply by 5. And when you multiply by 5 there, you'd get your 4.5 grams. So 4.5 grams is the answer to that. So for 500, I need 4.5, okay? So sorry, now I'm not finished that. I have to do the last part of that. Just 2 seconds now, and I'll get rid of this. Okay, so for the second question there now, they asked you, a can of beer contains 21.5 cubic centimeters of ethanol in the can, and there's 500 cubic centimeters of beer in the can. So look at the information that you're being given. 21.5 cubic centimeters in 500 cubic centimeters, okay? Calculate the percentage alcohol in the can, percent V by V. Now, what does percent V by V mean? Well, percent V by V means that you need so many cubic centimeters in 100, always 100 cubic centimeters. Here, currently, we have 500, so this time you have to divide by 5 to bring it down to 100 cubic centimeters. And when you divide 21.5 by 5, you'll get 4.3 cubic centimeters. So you would rewrite that then as 4.3% V by V. Okay, thank you.